record to cloud. Sweet. Yeah, so you can install Jupyter with either pip or conda. And then once you do have Jupyter installed, we can work with them. We can work with a Jupyter notebook. And here, after you run the command, this is the wrong one. So here I was just showing Python-v. I'm working in Python 3.7. That's fine. 3.8.3, I think, is the most recent version. And once you have Jupyter installed, if you just type in Jupyter Notebook, and let me make this bigger so that you can actually see. I just typed Jupyter Notebook. I'm specifying the IP that I want my local like server to spin up at 000 and then port 888. Yes, thank you, Sailor, for pointing that out. I will be sure to have that updated. I'll also share my slides. I don't have slides per se. I have a blog post that covers everything that we're going to go over here, and it has the appropriate links for everything, which I will share right after the workshop. So once you fire up your Jupyter Notebook server, you will get, not Slack, don't show me Slack. It'll take you to a page that looks like this. Here I have the source code that we're going to be walking through, and I'm just going to do it live in this blank notebook over here. And does anybody have any questions up to this point? I hope that people were able to come with these requirements pre-installed, but if not, I can totally wait 1 or 2 more minutes just so that you're able to actually follow along with me. Additionally, if you don't want to install Jupyter, you can totally do this just like within the idle editor. If you wanted to, that's a bit barbaric in my opinion, but it would work, or any other just like Python editor that you want to use. I will give that a second. Yeah, and then I think we can get started if there's no questions. So the premise of the project, what we're going to do is try to web scrape IMDb for movie reviews and review usefulness scores for the top 250 or so movies on their list. If you don't know IMDb, it's just like a movie database that's publicly listed. People can leave their reviews and whatnot. And they have this awesome top 1,000 movie list. So if you're ever bored on like a Friday night and you're like, hey, I want to watch a movie, but what's good? You can head over to IMDb. And they have a ton of crowdsourced information about movies. And so we're going to try to do, we're going to gather a bunch of data so that perhaps in the future we could do some like data science, machine learning, or whatever to find trends in that data. Perhaps some naive sentiment analysis to gain some insight into like metrics about what kind of movies or like what is an indicator of a good movie? Is it the star rating, or is it the kinds of words that people use in their reviews and whatnot? Before we can get into any of that interesting analysis, we actually have to fetch the data. So we're going to be using Beautiful Soup 4 as our web scraper or web scraping library. You can install that. Let me send this just to chat with a pip install Beautiful Soup 4. And we're also going to be using pandas to quickly store that data into a data frame, which we can very easily write to a spreadsheet like a CSV or something like that, a pretty standard file format. So along with Jupyter Notebook, you will probably also want to install those 2 things if you don't already have them. Beautiful, they're both pretty standard in my experience. But yeah, if you don't have them, that's no worries. It's very easy to install. So the first thing that we're going to do, or the first step, if you will, is write all of our import statements for the different libraries that we're going to use. So we're going to use BS4. Obviously, that stands for Beautiful Soup, and that's the thing that lets us actually interact with the parse tree that we'll get from requests to different websites that have all of our data. We're going to import pandas as PD, because I don't want to spell pandas incorrectly this entire workshop. You already saw why. We're going to import requests. That's kind of like just curl essentially for Python, but it's way more powerful in my opinion. Actually, I take that back. It's nice. We need it. We're going to import NumPy as NP, which I don't know if we're actually going to use that. I think we'll use it to fill in values that we can't find, so not a numbers. Pandas has its own NaN value, not a number, but for whatever reason, NumPy's is better in my experience, which is peculiar. We're going to import CSV so that we can easily write our output to a CSV file, and then we're going to import time so that we can set a delay in between how many times we're going to query the IMDb page so that we don't get timed out by them. Now, if you haven't used a Jupyter Notebook before, you can run a cell and create a new one by hitting Shift-Enter here, import pandas as PD. Shift-Enter will run the cell. See, it showed us our error. There's no module called request. Nice. Eventually, it works like that. And now it kind of caches the result of all cells above you. So down here, even though like we're in a different cell, we're still able to access everything that we wrote in this cell above. And if we said like a variable x equals 5, we could do that. And then if I just typed out x, it'll automatically print it. So it will remember all the values from previous cells, which again is why it's super useful for just like rapid development or exploration of data rather. So before we jump into things, generally the web scraping process follows like a general approach loosely around the following like 3 steps. You want to identify your target data source. You want to go visit that data source, like the actual website page itself, and try to examine its layout to find patterns that you might be able to structure code around. Like, oh, hey, if I write a for loop that iterates over all of these like bullet points, I can extract the data I want. It's nice to be able to find those patterns before you get too deep. And then the 3rd step is obviously to write, test your code, iterate, etc. So like I mentioned, we went to, that doesn't exist. We're going to go to the IMDb top 1000 list. Let me drag this over here. And I will send a link. But this is basically what we're looking at. And one thing that stands out to me right off the bat is that URL. We can see that they've packed a bunch of parameters into the URL itself. I don't know if you're familiar with how URLs work, but if you see a question mark, that means that there's an argument and then an equal sign, which is the value that we're actually going to be working with. So we see question mark count equals 100, question or and groups equals top, that's another parameter, underscore top 1000, and sort equals user rating. So the base URL, let me just copy and paste this over because I think it's useful. Usually that's cheating in a workshop, but it'll help make my point. Let me make this smaller so that you can see. So yeah, this is our base URL. It's just IMDb search by title. Which list we want to view is the top 1000. I have in mind a view equals simple, just so that it's a compact. If it was, yeah, this is actually not the simple view right now. And so we can see a whole lot more information, but as a result of this information, there's going to be fewer reviews per page, which means we might have to go to more pages, which just takes longer. So if you go to compact view, you can fit more information on the page. Ampersand sort by user rating, comma description. That's how we want to sort the rating. And the count is how many we want to view per page. For IMDb, I happen to know that 250 is the max. It's like how many Amazon items do you want to see per page. 250 is the max. That's fine with us. It would not be too difficult to programmatically change this in a script. If you wanted to actually get the top 1000, you could say like, do this 4 times, do it like I times 250 plus 1 or whatever, starting at whatever. So, and actually I have an example. If you wanted to do that, you would say count equals 250, and then you could change this to say like start at 251. That'll give you the next 500. But for the sake of this workshop, we should have more than enough data from just 250. So let me actually clean up this URL and go take a look at what it looks like. And I'll share this one in the chat as well. Send me some kind of Zoom reaction if you've ever used inspect element to impress your friends, like in middle school, maybe this past week. Doesn't matter when. Inspect element is awesome. Just the developer console on any browser. I don't actually know if I can see the reactions here, but yes, at least one person. Okay, here. And I've accidentally grabbed the other one. We want to start at either 0 or 1. Let me check. I think it's 0. Yeah. And so this is the view that we want. And here we go. The #1 movie, according to IMDb, is The Shawshank Redemption, followed by The Godfather, The Dark Knight. All these movies look pretty awesome. If you haven't seen them, I definitely recommend checking them out. A ton of other people have said that they're awesome. So the first thing that we can do is pop open inspect. I'm on Chrome. I think it has different names on other browsers, but it does the same thing. And what we want to do is fetch data for each of these, right? So what I can do is move this up, and using the select tool over here, I'm going to try to find, here, this div. There's a bigger one here. Yeah, div lister item content. That seems like it has a consistent name across the entire page. So like we can imagine that there's one big div container that has all of these bullet pointed things. And let me close this as well. Each of them is a lister item class, which is perfect because that is like a pattern that we can match against. These are stored within a span class, which maybe it's inside here, list call wrapper. No, there's a span somewhere out here. But inside of the span, there is an A tag that has the actual link to the movie itself right here. Yeah, here's the span, sorry. The lister item header has the title, and inside of this span is an A tag. Now I know that this is like a little bit very much in the weeds, but this is the kind of thing that you have to do for that first step, which is, or the second step rather, which is examining the pattern. So you don't have to have a ton of like HTML and CSS experience, really no CSS experience, but HTML to just understand the structure. And even without knowing like what all this stuff does, I sure as hell don't know why in the world they would nest, what is that, like 8 divs inside of one another? That's disgusting to me. All we care about is that like, hey, starting at this spot right here, there's information in here that we want, right? Now, if we take a look at the #1 rated movie, for example, if we click on it, we can navigate to the user reviews page by clicking on this link down here at the bottom, reviews. And right there on the, let me actually click this so that we can view here. This is going to be an href, and it's going to go based off, I can't move my mouse to see it, but you see that little pop-up that says imdb.com/title/TT, and then there's like a unique code that corresponds to this movie. And so we can kind of assume that every other movie will also have a similar unique code. And then the subroute, branching off of that is reviews ? So there's an argument being passed in, and it says TT_OV_RT, which might sound like overall rating, right? If we navigate to this user reviews page, we can see that, yeah, this is our URL now, imdb.com/title. So we can always count on our base URL being /title. And then we're going to have some argument here, which is the ID of the specific movie. But we got the ID from that specific movie from that A tag on the like 1000 list. So we can also probably extract this information. And then this is a constant. It's always going to be reviews sorted by overall rating or whatever. So now let's take a look at what kind of information is actually stored on this page. Here's a lovely review called "Some Birds Can't Be Caged." And we want to find like the outermost div or object, yeah, this one, that contains that. Each review is contained within a div element that has the class IMDb user review, which we can see right here. That's cache. That's very good. If we scroll a little bit just to see, we can see that some movies will have a star rating. This user like elected to give it a 10 out of 10. This is how movies should be made. This user said prepare to be moved, but not enough moved to be a star rating apparently. That's fine. We just have to account for that, because if we go to look for a star review and it doesn't exist here, our script will break. So that's the kind of thing that you kind of want to pick up on. And even if you miss it, you'll eventually find out when your script doesn't work because speed read didn't want to give us a star rating, and that ruins our whole script. We also have a date that it was posted. So this is 20 years old. And it'll also have the username of the author. We have, of course, the text of the review itself, which is very valuable to us if we're trying to do sentiment analysis or something. And then this is also a pretty interesting statistic down here. We have the number of users who found this review to be helpful. So you can sign in to vote, and it's like, was this review helpful, yes or no? And I think you can sort by, yeah, helpfulness is what it's already being sorted by. So if you have a troll on a movie or whatever, and they're like, this movie sucks, when it's Shawshank Redemption, objectively, it does not suck. This movie rocks. Trolls will get downvoted and they're not going to show up in our script. And the reason for that is because this page will only display 25 reviews at a time. Using Beautiful Soup, it's not possible to click this load more thing. However, there are more robust like web scraping tools. Selenium would be the one that I'd recommend, that emulates a headless browser, which actually lets you go like click on objects or click on stuff and interact with the page more significantly. But again, we just need 25 reviews per movie for 250 movies. That's so much data. Will be all right, even 1,000 movies. So we have a pretty good handle on the layout of what this page looks like. So now I think our goal is going to be get a link for all 250 movies, and using the link, that unique code that corresponds to each movie, that's this number up here, we can go to this user reviews page because the route here is constant. And then we're going to write a script to go pull as many of these reviews as we possibly can. Does that make sense? Are there any questions so far? I know that this might seem overwhelming and non-intuitive, but once we actually dive into the code, I think that you'll have a better idea of how we're actually interacting with Python, or using Python to interact with the website. But I definitely want to take a pause to catch other people up to speed if need be. And I've hidden the chat. Come on, Peter. No problem till now. Okay. So let's go back first. I think a good starting point, not on this one, but on this page. Let's try to write a script that will, actually, let's work the other way. Let's work backwards. We have a good handle on the layout of the patterns of the two main pages that we're going to be working with. So let's write some code to like systematically extract the above data points. That was like the star rating, usefulness reviews, and the actual text. If we can do that for one, it should be easy to adopt our script for 250 of them. So let us define this to be our like URL for the top 250 movies. So I'm gonna call this URL movies 250, and that's gonna be a string that is imdb.com/search/title grouped by the top 1,000. View is equal to simple, and the sort rating, or sort, is by the user rating, and description. The count is gonna be the max that we want of 250, and I would like to start at the 0th movie. That way we get the best films. I'm not here for no 250 best films. I want the best that IMDb has to offer. So we can just hit enter. And once again, this variable is just like stored now. We can use it anywhere else. Oh, that's not what I meant. We paste this. Why is it copy, paste? There we go. Excuse me. We can see that it's storing that value, which is pretty intuitive, but neat anyways. So let's build a data frame that will have, and think of a data frame as like an Excel spreadsheet. It's just a spreadsheet. We want to have columns for the name of the movie, the average star rating, the date that movie was released, or we should probably build it around reviews instead. So the name of the movie, the stars that user gives to a movie, the date that review was posted, the author of the review text itself, URL to that review, as well as its usefulness score. So I'm going to call that just df. That's pretty standard shorthand for data frame. I'll say df is equal to pd.dataframe with capital D and capital F. And we're just going to define the columns that we want to be in our data frame. And like I said, I think it's worthwhile to store the name of the movie that they're leaving a review for, the stars rating, if any. They might not give it a stars rating, the date, the author associated with that review, the review text. This is such a pain that you all probably can't see that. Let me put it up here. If my font is like too big or too small, feel free to let me know, but here we go. Name, stars, date, author, review text, URL to that review, because each of them also has a unique link. I don't know if I showed you that, but if we go here, you can like click on this hyperlink right here and it'll take you to this page where people will write books about movies that are about books. It's kind of ironic. we also want to store the usefulness of that user's score. And if we hit Shift Enter, we don't get any issues. It says that that's good to go. So now let's write a function that gets all of the info for one of these movies. We're going to need the URL of the movie, which in this case is like imdb.com/title, and then it's this, I believe. Yeah, this would be the URL. And we're also going to pass in this data frame because we're going to keep inserting data into it. So I'll say def get _movie _info. And like I said, we're going to take in the URL of the movie as well as the data frame that we're going to store it into. Let me get rid of that output because I don't like it. So the first thing that we want to do is make a request using the request library that we imported up here on line 3 on this page. So that way we can actually get the like the code back from it. That doesn't entirely, we'll get the source code back from it, and using the source code, we can use those patterns that we identified with inspect element to extract specific data from it. So I'll say response is equal to requests plural dot get, and then we'll send in the URL. Now, again, this is very similar to just like curl or any other response or like fetch API library, anything like that. And it's best practice to check the response code that we get. So it could be like a 404 not allowed, or a 405. Perhaps you can't use get requests against this endpoint or something. It will almost certainly be a 200, which is success. But in the case that it's not, we want to check if response.status _ code does not equal 200. Then we're going to want to like printf get request failed or something, get failed with response code. And it's probably worth printing out what that actual code is. And so we can just snag it right here. So if it's not a 200, 200 is a success code, then let us know that we failed. And we can also raise an exception. That way we don't get any further in the script. Because if we have a failed response code, none of the code that we're about to write is going to work. So now let's instantiate an instance. Let's get an instance of beautiful soup. So I'm going to call it m_soup for a movie soup. And we can call this or equal to bs4, that's beautiful soup 4.beautiful soup in all caps. And we're going to feed into this our response.text, which will be like the input. That's the entire response that we get from looking at this page. And we also want to, and actually, I think we're going to end up passing in this URL for what it's worth, because this is more useful. The second argument that you pass is which parser. There's a few different parsers. There's an HTML1, HTML5, an XML. I'm not sure about the rest of them. The beautiful soup docs definitely tell you that all the different parsers that they have and the advantages and disadvantages of each. I'm going to stick with the HTML parser because that's what I'm familiar with. But I encourage you to read the documentation to check out what else is available. So the first column that we have here that we're trying to populate with this function is name. So let's get ourselves a name, and it's going to be equal to msoup. And again, this is like, at this point, this is a huge tree of sorts that we can parse using Beautiful Soup's methods in ways that don't make us think about it like a tree, because that's painful objectively. We want to find the name, and here we can probably see that, oh, I already have inspect element open. What is this? This is the title of the movie down here. I'm not sure if you can see it. And it's within an H3 tag that has an item prop called name. There's an A tag inside, and this value right here is really what we want, the Shawshank Redemption. So we're going to do a beautiful soup.find, and then we can tell it the name of the type of the element or component element, DOM object, if you want to be specific. Ours is an H3. We can see that right here. And then we can pass in some qualifiers or like further parameters to specify, because there could be like a ton of H3s on a page. I don't think there actually are in this case, but just to make sure that this is the one that we get, the one that says Shawshank Redemption, we can pass in a dictionary that has further parameters. And here's a unique parameter that we can assume is unique to this title up here. It's the item prop. I don't do a whole lot of web dev, but I rarely see stuff like item prop. Perhaps somebody who has more experience can let me know if that's a common like attribute on on web pages. But yeah, since it's a dictionary, we have to do item prop colon and then it is name like that. And there's one thing inside of this H3, right? If we did the H3 itself, it would give us another parse tree object. We want the first element inside of this H3 because this ahref is not useful enough. Item prop URL, if you search for that, there's several things that have URL in the item prop, at least on this page. We know that the item prop name is unique to this one. So what we're going to do is find the encapsulating object and just kind of drill into it. And the way that you do that is with contents, because this is contents will give us, excuse me, all of the objects in here as a list. And so we want to get the first one. Yeah, because I think that this is technically the 0th item, the item prop itself. And if we just do .text, this is going to give us the text of the title. And I think I can show you that. So if we just call get movie info on, let's do it for this one. This is our URL and our df is the same df. Let's just print out name just to do a quick sanity check. If we call get movie info, sweet, we can see that it's finding the Shawshank Redemption. That is perfect. So I'm going to undo this and let's move on to the next field that we're trying to get. All of the reviews. We want to find all of these 25 reviews. There might not be 25 reviews. There probably will be for like the top 250. But if you find like a terrible movie that only one guy and his mom watched, then there might not be that many reviews. So perhaps using a while loop instead of a for loop would make more sense. We'll deal with it. I have a question in the chat. Failing to get Jupyter run. Sorry about that. Here is the code that I have written so far for anybody who's following along. I know that pasting, oh, let me send that to everyone actually, sorry. Copy pasting from Zoom is torturous, but it's probably better than nothing. And like I said, all of the code that we're going over here with way more comments explaining everything and pictures associated with the rationalization will be available after the workshop. In fact, I think they're available now, but I don't want you to get too ahead of me. So we're gonna keep going. Let's grab all of the reviews. So we can just store those in a list. And we can do reviews is equal to msoup. Again, that's our instance of beautiful soup. And I'm gonna do a find all. So this will return a list. If we do soup.find, that'll return the first instance of what you're looking for. So again, maybe we don't need this whole qualifier for the item prop name if this is the first H3 on the page or the one that says Shawshank Redemption. But this is just kind of to show how you can be more specific and find the unique attributes of the different elements. Find all will return a list of all of the things that match whatever pattern we give it inside here. And so let's take a look at what our reviews look like. Again, I think we found that they have this thing called user review, if I'm not mistaken. Yeah, this thing right here. So that's what we're going to target. We'll do find all, and it's a div element. Divs with the class. Again, class is just any of these like orange parameters. That's not the right word. Attributes, those are attributes. You can specify attributes here. It has a class attribute, and it has the class attribute of IMDb-user-review. And yeah, that should give us all of the reviews. So for each rev in our list of reviews, let us try to extract the star rating first, because I think that that's the most like quantifiable thing other than the helpfulness, but I like stars. But keep in mind, there's not necessarily stars for every single review. Like our code will break if we assume that there's a star value associated with this review. So I think it makes sense to put this in a try except or like a try catch statement if you're familiar with Java. So we'll say that the stars value is equal to, it's going to be a rev.find because now we're in this specific review right here, or we're looking at one review. Let me find one that actually has stars. That will make more sense. We're in this review. Let's take a look at these stars numbers over here. Okay, we have a span, some classes. I should drag this up. We've got a whole lot of stuff going on. Rating, other user rating. I think that's the easiest thing to identify. Latching onto an SVG doesn't seem too fun to me. I don't know about you, but this span contains that star icon as well as the span that says 10 out of 10. We know that the scale is on a 10, or like it's out of 10. So we really only need to go for this middle span right here. So let's do rev.find. We're looking for a span, and we know that it has a class of rating, other user rating. Look at that. That's awesome. Just paste that right in. And this is going to give us, again, everything inside of this span. So there's one thing here. Well, it's the first thing, or zero thing. First thing, second thing is this 10. So let's get dot contents 3. And then once again, we can do dot get text. You can also just use, you can be a barbarian and go straight for the text field itself like that. It's not private. That's even a thing in Python. But you can also use the get text method, which will handle some of the nastier Unicode stuff that you might run into. And thinking forward a little bit, we don't want to work with star reviews, like a numeric quantity as a string, which is what this is on the web page. It's a string. So we can just go ahead and slap this into an int cast, and it will make this a number, which is going to be useful for us. What happens though if it can't find this, and then we call a dot contents? Like if it doesn't find it, oh, and this needs to have a closing parentheses. If rev.find doesn't work, then it's going to be null. And if we do null.contents, null.anything, that's a null pointer error, it's going to fail, which is fine. It wasn't able to find the stars. We put it inside of a try except statement. We're ready to handle that possibility. So if there is no star rating, we're just going to throw in np.nan, and we're going to set that equal to the star rating. Nan is used for like values of infinity or invalid values, empty values. Like if you're making a survey and you don't get a response from somebody for one of the questions, it's not, if it's a numeric thing, you don't want to put like 0 or -1 or something like that. That might mess up your computations. Maybe you do, it's up to you. np.nan is also totally fine. The next thing that we want to get after we have the stars is the date of the review, which looks like it is just right here out in the open. And it has a span with a class of review date. It's like shooting fish in a barrel. So much easier. So we can do date is equal to rev.find. And one thing I do want to point out is here we were doing msoup equals, or like msoup.find. Each beautiful soup object itself is a tree. So msoup is a tree, and each sub part of it is also a tree. And so all of those same functions, find, find all, etc., work on these sub parse trees as well, which is pretty neat. So we can, instead of having to search the whole page, we can just search this one review, this one component that we're looking at. And so we're just going to do a find. I'm pretty confident that this is the only thing that has the review date class in it. And so we're going to do a span, because that's the kind of element it is. And then in a dictionary, it has the attribute class with a corresponding value of review date. And here in my slides, I have something about being sure to encode it in ANSI text. And I'm trying to remember why. I think it has to do with the way that this is being encoded as a span on IMDb. Yeah, maybe I'll take that out and see what happens. But just to make sure that the end result works for this workshop, I'm going to do .text. So that'll give us 18 February 2008 if it's looking at that review. And I'm going to encode it as ASCII, and ignore is the second parameter, which I think is like if there's characters in there that it doesn't recognize. I think that that's why we did it, is there's like weird white space characters or some dates can be invalid. So if we encode it in ASCII and then do a .decode, that will, if it has characters that we can't look at easily or can't store in our pandas database, if we just encode it to ASCII and then decode it, those characters just get disregarded, and it saves us from having to wrap this in like another try except and potentially not have any data at all. I think that was the rationale behind it. Sorry, I don't have a better answer off the top of my head. That's also just not an uncommon thing that you'll see in data science, is like these preliminary steps to make sure that the output data that you get is somewhat clean. So the next thing that we're going to grab is the author. I'm sorry, I'm taking it up a little bit, but I'm going to speed it up because the rest of these are pretty similar, and we still have to get all of the movies. And I want y'all to see that before 1 o'clock. So author is going to be a rev.find. That is going to be right here. It's right next to it. He also has a unique thing. It's display name link. And except his, again, he has an A tag inside of it. So we need to do that contents sub-indexing thing. So it's in a span. Span has a class corresponding to a display name link. And its contents, we're interested in the 0th element of that. And I think we're going to do the same encode decode thing because there's very loosey-goosey rules in terms of what kinds of characters you can include in your username. So we want to get the contents of this, which is going to give us this aref. We want to get its text, and then we want to encode the text and then decode the text just to strip it of any illegal characters that we don't want to worry about. Now for the review text itself, this is also going to be pretty straightforward. It's just inside of a class called text, show more, control, clickable. Yeah, we want all of that stuff. So we'll just say review underscore text is equal to rev.find. It is inside of a div, I believe, yeah. And the div has an attribute with a class, or an attribute class called content. Which one am I looking at? Yeah, this content right above it. And so that's going to give us this whole div, but we want the contents of this content div, which is a mouthful, but I hope that makes sense at this point. So we're going to do contents of 1 to grab the next thing. We're going to grab the text, we're going to encode it, and I'm going to copy this same thing. .text, .encode, .decode. Hopefully that works. Sweet. And then let's find the URL of this review itself, which is up in this hyperlink for the name of the review. I don't care about the name of the review per se. Class title, that looks like it might be unique. Title is pretty ambiguous. I'll let you in on a hint. This will work for this one, but it might not work for like all website layouts or whatever. Once again, we know that these leading parts are going to be static. And so we might as well just store those static fields as well. And so we can make this a formatted string that says imdb.com. And then we're going to include that reference number right here, which is like the name of the movie, which we can do inline. We can do rev.find. It's an a tag, excuse me, with a class called title. And we want the attributes for the aref, which is /reviews/this. So .title .attrs, and that is a list, or a dictionary rather, excuse me, called href. Now this is pretty messy, but basically it's just going to build this review link for us. So imdb.com/reviews. That's what's going on inside here. Does that make sense? That might be a little bit confusing. You could also definitely split this up into 2 lines, but just for concision, I've grouped it up into 1. Now we're going to take a look at the usefulness scores, which are these things down here. They're in an actions muted tab. This looks disgusting. What are we going to do? Probably just use the tools that we have as we've done so far. So I'll call this usefulness. and it's going to be rev.find. This is inside of a div. The class has a thing called actions. So say class actions, and yeah, this will give us all of the text in here, and we can probably just do like a string split, grab the first number, grab the second number, and store those. So we'll do .text .split around the dot, I believe. That doesn't seem correct. Split around a period. Let's see why I did that. I don't think we would want to split around a comma. And if we do strip, that will remove all the excessive white space, because if you can't tell, there's a lot of white space here. So I think it's going to split it. We're going to get this first chunk, which would give us like this whole blue highlighted thing. And then once we strip, it'll just give us that. And we can pretty easily extract these middle two numbers here. So next we can say that usefulness is equal to, right now usefulness is a string, right? We get a string back here. Now let's do usefulness dot split around white space. So we know that the 0th element is going to be our first number, and the 1, 2, 3rd element is going to be our second number. So how many people found it useful out of all the people that have checked this review. So we'll split it around white space just like that. And then once again, we can store it as a string, which maybe you might not want to do. You might want to instead treat it as a number, but as an F string, I'm just going to take the usefulness of 0, which again is this first number, so 1632, and divide that by the third thing over here, which is 1873, usefulness of 3. And then once again, we're going to do dot encode ASCII and ignore to get rid of any fake numerical characters that IMDb might throw at us. I know I've included this for a reason, so there probably were some wonky reviews in there. All right, now we have all of these columns that we wanted, right? Now what we need to do is append them to our data frame. So still inside this for loop, because it's going to go over every single review, we'll do frame equals frame dot append. Typically, you'd think that you could just do a frame dot append, but Pandas has a weird thing with whether or not you're appending something that has the same index. If you like try to append one data set to a different shape of a data set. So we're going to do frame equals frame dot append. And here we can just give it a dictionary that includes our name, and that has the name. It's going to have the format nicely, please. The stars, that's going to correspond to our stars value. I swear, it's not going to align for me. The date, which corresponds to the date. We're just matching up all of these column values. The author corresponds to, you guessed it, the author. And the review text corresponds to the review text. And I think the last thing that we have in here is the usefulness score, right? Yeah, that's what we just got. So usefulness is equal to usefulness. And then we can close out this dictionary here, and I'm going to throw in ignore underscore index equals true. That is a Pandas thing. Like I said, if it's a different shape or if it's not expecting something that looks like this, it'll yell at us. I don't want to get yelled at. So this frame for one movie will get all 25 reviews, and it's going to return it to us here. After we've done this for loop, let's return the frame to the user. See how it works. Let's grab this movie, and we can do df is equal to get movie. Actually, we can just print the frame in here, I think. I don't even want the frame. Print frame. How's that look? Invalid syntax. Can't all be perfect. I knew that there was going to be at least one disgusting syntactical error in here. I would have been impressed with myself otherwise. To cast this to be an int, this whole thing needs to be an int, I believe. And I also need to call get movie on the appropriate thing, which is going to be Shawshank Redemption here. And our frame is going to be good old DF. That one worked. That one appears to have worked. So it's printing a frame, but this frame is empty. Pray tell, why? I think I might be on the wrong URL. Does it need to be this one? No, that definitely doesn't make sense. That is peculiar. It's because frame is empty. We're appending all this stuff. Print frame. Yeah. Huh. I'll have to take another look at that. I'm going to move forward and I'll correct this code to see what's incorrect with it or what's broken about it. He thinks it might be the appendage right there. Yeah, the next thing that we would want to do if this had worked, which it should, the source code works, is repeat that process for every single one of these movies, right? That way we get 25 movies per review. So what we can do is just in a script out here, we'll do response is equal to requests. You could also put this inside of its own function. I'm not. I'll say response equals, call it on this, the URL movies 250. And once again, we're going to, you should check if the response is not appropriate, do that, which we can just copy. Otherwise, let's keep chugging and we'll call soup is equal to, I'm going to copy this as well, bs4.that. .beautiful soup, we're going to send in the response text using the HTML parser. And we're going to get all of the movie links, which are going to be the A tags inside of this, the blue purple links, right? So movie links is going to be a kind of disgusting list comprehension. Bear with me. Where is it? Yeah, so we're going to do m.find. M stands for movie. We're going to find the A tag. We're going to get its attributes, which is a dictionary, and want the href. So that's going to be, imagine this is one M in our thing right here. We're going to look for an A tag that has an href. There's only one A tag deep inside here. This is its href. That'll take us to the movie. And we want to do that for every single movie in soup.find_all. And we're going to look for this whole span, which, yeah, is the lister item header that we saw from earlier. So do that for every single span with the attributes of a class called lister-item-header. This is kind of a criminal line of code, but it's kind of neat that it works. Then for every single link in our movie links, we would just want to, I'm going to throw in a print statement here so that we can see it kind of chugging along. This is a very gross, a very loose loading bar, to say the least. So say print a dot, and then we can do m_URL. Again, we know that these are static, right? So this can be a format string that, format string that looks like https://imdb.com. And then we can input that link that we got, because if we look at this A tag, it has a leading slash, and it's /title/ the unique code of the movie with some arguments in here about how they should be sorted or whatever. So we'll do /links, And then we also want to look at the reviews. And we know that the reviews page for each of these movies is static after that unique movie title. So if we go back to, for example, Shawshank Redemption, click reviews, everything after that slash, we can just copy. And we could also change like sort by review date, sort by other stuff. Total votes, that might be interesting. That way we only see like the ones that have been voted on the most, because you could have something that's very useful, 100% useful if one person found it useful out of one person. So let's sort by total votes up here and see what that looks like. Yeah. So it's reviews, question mark, sort equal total votes, and the direction is descending order, I think. Yeah. And rating filter is equal to 0. Filter by rating, you could have it only show you 10 stars, but we want to kind of get a diverse, highly voted upon data set. That's the idea. And then for every single one of these movie URLs, we want to append it to our data frames. Let's do df equals get underscore movie, and we're going to pass in the M URL as well as the df itself. And after we do that for every single movie, we can print out our data frame right here. It also makes sense to do a wait, which is why we included time up here. I think you could do like a time.sleep. Let me check the source code. I took it out because I was impatient, but this is the kind of thing that you might want to, oh, I didn't, there it is, time.sleep. You would want to include something like this because it's kind of rude to send a bajillion requests to IMDb for no type of reason, or not no type of reason, but just without any delay, they will time you out. So I know that you can get away with doing this small amount of requests, but it's definitely worthwhile to consider if that's not the case by adding a timeout. Request plural. Always request plural. Okay, and so this is going to go, and it should print out a dot for each movie that it's trying to scrape. Oh, found something wrong. String has no attribute ATTRs. That's in the movie link. What did I do wrong? M.find a, oh, this. It's got to close right after that. For in loop. So now we sit. There's just kind of, while we wait for this. Oh, I don't get the chance. Get movie info. Come on, Peter. Jupyter has a ton of really nice extensions similar to VS Code that make working with it not light mode for one, way less painful, just pretty sweet overall. Okay, sweet. Here, I think we're still printing. Are we? We're not printing. Curious why it's telling us that we have an empty data frame. Let me compare this to the source code. And once we get this to work, the workshop will basically conclude. So if anybody has any questions while I try to find out where I went wrong, feel free to drop those in the chat. You can see everything is much more nicely commented. Parser, item prop, contents, text. That looks right. Div class, IMDb user review. Yeah. For Reven reviews, span class. Contents of 3.getText. I like to see that. Otherwise, it's a nan. I could also just run this one, and I'll let you know if I find out what I did incorrectly. But here we can watch it go, which it should. I'd be curious if perhaps IMDb has restructured the website. That is possible. That'd be rude. That would hurt my feelings. I put this workshop together earlier. Now here we go. It's chugging along. So if you're in your split of the actions, I think I'm stripping the list. I forgot 0. Thank you. Good call. Let's take a look at how I'm splitting here. This one is also splitting. Oh yeah, and then I'm stripping a list. Good call. Now, if we rerun this one again, they might both be going at the same time, which kind of defeats the purpose. Now I will get blacklisted by IMDb. And so this will run for a while. I don't know if y'all saw earlier, but it will wrap around twice. So I think what I'm actually going to do, just for the sake of time, is we can go back up to our original URL list here, and I'll say I only want 25 movies instead of 250. And let me stop this cell from running and rerun it. I'm going to move it over here. I might have to restart the kernel. It doesn't like when you interrupt cells. I'll give it one more second. But yeah, let me share my slides in air quotes here. Has a brief write-up of everything that we went over, has all of the code with the comments and some further explanation, some screenshots, pretty much verbatim what I said. But yeah, are there any other questions or any questions at all about just web scraping in general, Python, Beautiful Soup, Pandas, anything that we've gone over at all? I'm more than happy to try to answer. It would be really cool if this would show up. Okay, so there's going to do one. This is redoing the live one. Don't redo the live one, this one. The actual one is going right here, which is what we want. Thank you, everyone who was able to attend. I appreciate it. Best of luck with the rest of your hackathon projects. If you want to stick around and wait for this to go through 25 blips, we can see the very cool data frame that will pop us out. So there's a question in the chat that says, what got me into web scraping? How did I start learning more about the topic? I was at a hackathon and I was literally trying to do exactly this. I wasn't able to figure it out, but I found Beautiful Soup and I was like, oh, hey, this is pretty cool. I can go steal data from other websites. It's not necessarily stealing if it's publicly available. Yeah, it's like if you want data and there's not an API for it, then you might have to build that data set for yourself. And so if you're not familiar, one common use for this would be like a D&D API. This is something that I know exists because I've used it. But if I wanted to make an API or use an API, make like a Discord bot that my friends and I can use when we're playing Dungeons and Dragons that lets me know like the name of an acid arrow, the description, all this other stuff, but nobody has gone through the trouble of packaging it up into a nice format like this, then what I would have to do is go to like D&D 5e, go find a website, see if like fireball spell. Yeah, Roll20, sure. So here's a website. I happen to know that all of the pages for all of the spells look basically the same. And so we would go back through that original process of being like, hey, all right, here I can figure out the name of a spell. It's right there in the H1. Here I can see all the attributes. They've got some funky text stuff going on, but I think that Beautiful Soup won't see it. And so I can just yoink every single one of these fields and package it up into like a JSON or something like this other person did for acid arrow or whatever. But in the case that information doesn't exist in an API, perhaps IMDb isn't the best example because IMDb has a ton of APIs so that you don't have to go do these manual queries for data. It has a very nice structure though. But yeah, I got into it because I was working on a hackathon project and I was trying to use data that nobody had cleanly packaged up into an API for me. And that's when web scraping is useful. Additionally, you can automate a ton of stuff. I briefly mentioned Selenium, but I wrote another program for my brother. He was doing like hurricane relief in Ponce, Puerto Rico. And they had this super complex like proprietary system where they were like trying to export lists of data about people's whose homes were affected by hurricanes or whatever. And they just had to do it like every 5 minutes, or not every 5 minutes, but like every hour we need the latest update. And some guy would just have to go through and like do a bunch of spreadsheet monkey work I was like, hey, I can use Selenium to automate that process of interacting with their website, pull that data, upload it to some other website to display it more nicely. And that was really cool. That's a bit different than web scraping, but it's in the same vein of like picking apart websites into their constituent parts, to find out like how I can interact with them in an automated way. That is the overall goal. Scrape is still going on forever. This looks like it's way more than 25. He's definitely looking at 250 movies. Count is equal to 25. I don't know why he's still going. What about the live one? Live one cut out because I have a typo in here somewhere. And yeah, I'm pretty sure the slides for anybody, I did post them, the slides, the notes, I posted them in the Zoom, but they're also totally available on the live site right over here, as are the slides for a ton of the other workshops. And hey, I'm only 5 minutes over time. That's surprising. Yeah, I think the slide/Vada right here, be sure to upload those. Yeah, that does link to the correct spot. Sweet. And here we go. This is what we're after. We get this nice spreadsheet looking thing that has, oh, hey, here's the movie. Here's the amount of stars that this user gave it. Remember Speedread, he was the problematic guy who didn't give us 10, or he didn't give us a star rating. And then we have the whole review text, which we could do NLP stuff on. We have a link to the review if we need for like archival purposes or whatever. And then we have the usefulness, which we could very easily cast into a more numerical value. If we wanted to get this as like a percentage or something. We didn't get to do any of the data viz stuff or the sentiment analysis, but that's hopefully you're able to take this process. If you already know how to do the NLP stuff or the just analytics, this is how you can get yourself a data set. And that's the goal of the workshop. So yeah, thank you again to everyone for attending. If you have any questions about this stuff, I'm obviously going to be in the Discord all day long, so don't hesitate to hit me up. And yeah, best of luck with the rest of your projects. Now to figure out how to end the meeting without losing the recording.